Hey Matt, hey Aaron, hello everybody.
Hey, Paul. Matt, you're on mute.
Hey everyone, done off mute.
Well, we thought we'd do a bit of an impromptu stream today, but there's been a little bit of prep work about this. Like the three of us have sort of been discussing this specific topic for a little while, and the topic today is .NET Core in AWS Lambda. I've worked on a couple of different projects where we've run whole web API within Lambda. And we were just chatting about that and how that can be a fairly useful transition. It's quite helpful to go ahead and move an API across into Lambda, especially even if it is like C#, and even if you're moving across a whole API. If you're using or used to using something like SAM, if you go ahead and create a C# SAM project, you get a really close one-to-one mapping between the function itself and the API endpoint. But Aaron and I and Matt were discussing about how that can be, quite useful if you're building like out a service that has a number of different endpoints, and that might be a microservice. And let's just say that microservice is dealing with, I don't know, beanbags or something, right? And you could be creating, updating, deleting beanbags and doing some other things with beanbags, for example. And that's all like responsible for its own piece of data. So there's a number of different endpoints, a number of different methods. You don't want to have to go and define all these specific endpoints. You just want to proxy that the whole request all the way through to .NET and allow .NET to take over and intercept the response and go ahead and do what it needs to do within the .NET framework to provide those responses. And Aaron's been working on some of this for one of his customers and been playing around with that. And he's probably the most experienced .NET programmer out of the three of us. And today he's, we welcome him to come and do a bit of a walkthrough and setting this up. And interestingly, Aaron has chosen to go ahead and do this all on Linux. So it just goes to show how far .NET has come. We're no longer firing up Visual Studio, but you're going ahead and doing that. Look, the .NET work that I've done in the past couple of years has all been on Mac, but you can go ahead and be a totally proficient and have the access to the good quality tools on Mac and on Linux. Though I'd say Visual Studio on Mac is still not quite as good as Visual Studio on Windows, and Visual Studio doesn't exist on Linux, but Visual Studio Code does.
Yeah. So I'm actually used to using I come from a very heavy Microsoft environment where I'm used to using like Visual Studio Enterprise. So we have a lot of the enterprise level templates and packages and stuff that you just don't get or didn't get with like .NET Core when it first came out, and where .NET Core has gone in the last 5 years is amazing. And as you said, like I'm using Visual Studio Code on Linux. So it's sort of stepping out of my comfort zone. The last year, I've been working with a lot of other languages, and so stepping back into .NET, especially .NET Core 3.1. Things have changed since the last time I worked with .NET Core 2. Did a bit with .NET Core 1, and previously, like I was, all .NET framework. So, like stepping out of my comfort zone into doing it all on Linux, doing it all in Visual Studio Code. It's been actually bit of fun to see actually how powerful .NET Core is, and then also a couple of things that I had done in the past with AWS and writing Lambda and stuff, and where we've actually gone with the Lambda libraries and the templates that we now have just makes basically creating new projects super simple, but migrating existing projects, which is actually the customer work that I'm doing at the moment. Just to give you an idea, like basically we have a couple of different SaaS solutions inside an account, and we basically need to expose one endpoint for talking with or integrating with those solutions inside the account. And basically they had a .NET app, like it was a .NET API, and it was running on EC2. And basically we were looking at they basically wanted to make it serverless so that we could start taking advantage of Cognito and like some of the different features of authentication and authorization that API Gateway handles without having to build it all into the .NET app. So we looked at doing like a conversion of the .NET API project, and then like turning it into a serverless .NET. So it's basically API gateway with Lambda, but it's using the .NET Core API, web API project scaffold. So yeah, it's pretty cool.
That is pretty cool. So is the Lambda running on Amazon Linux then, or is it using Windows under the hood? I'm guessing it'll be Amazon Linux, right?
Yeah. So I've specified Linux, basically because it's a .NET Core project. You can specify Windows or Linux for the underlying operating environment. So we've specified Linux. I'm going to step through setting up a new serverless project, but I'll talk about like how we do migration and pulling across existing projects at the same time.
Cool. I'll put your screen up for everyone. So
cool.
Let's just pop it up now. Done.
So basically, like all I've done on this environment is obviously this is the environment that I was using for our Pygame stuff. So the only thing that's installed on here already is Visual Studio Code and Python. I went ahead and installed .NET Core for just 3.1 at this stage. I'm still sorting out a few issues with .NET 5. But at this stage, .NET Core 3.1 works exactly how I want it. So I'll just chuck this. If you want to post this into the comments so that people can see installing .NET Core into Linux using a script. So you can just download the script. It doesn't require admin rights, and you can install the .NET Core SDK into your environment. I went and did that already just because I'm using a different shell. So I'm not using just Bash, and I had to set up a couple of other things so that I could see .NET. So we've got .NET running, so we know it's there. What I'll say before I actually jump into what I want to do, actually, one other thing that I will do before I jump into showing you the project is the one thing that we've done at AWS, which actually makes this so much easier, is the Lambda library. So when you're actually writing like C# Lambda functions, there are other Lambda libraries, so you can download and install the NuGet packages for Lambda. But we also have the Lambda templates, and so those templates, if we go .NET install, we want .NET new install Amazon Lambda templates. Okay, so when you install the .NET templates, what it's actually doing, there we go, it's installed. What it's actually doing is it's installing, you can see all the templates that come with the SDK, Amazon SDK. Sorry, the .NET SDK. So all of the empty .NET Core project, all of that sort of stuff. If we scroll up, we can see, here we go. So we've got Lambda, a whole lot of Lambda stuff here. So if we wanted to create a new Lambda function, in the past, you just go like .NET new Lambda empty function, and that'll create the Lambda handler for you. Previously, the last time I did something like this, these serverless ones didn't exist. So what we actually used to do is we'd go and create our ASP.NET Core Web API, and then there was a bit of conversion work that we had to do to make the actual Web API work with API Gateway and Lambda. But what I found recently is we've actually done that work for you, and you can actually now run the actual serverless.asp.NET Core Web API project, and the work that you would have to do in setting up the Lambda handler, so actually the entry point for a Lambda, and then setting up the actual serverless configuration for the API as a proxy to the Lambda is all done for you. So let's actually go in and
nice.
do that.
And that's for 2.1 and 3.1 .NET, right?
Yeah, cool. At the moment, yes, 2.1 and 3.1. I don't think we've got .NET 5 libraries there in
I just saw at the top, it's a custom runtime, actually.
I think the .NET 5 is like on a Lambda in a container, right?
Yeah, it's not. It is available in containers, but not fully serverless like this yet.
Yep.
Are you sure? I thought it was there. Scroll up a little bit. I thought I saw it there.
Yeah, it's up the very top, actually. So right up. Yeah,
that's a custom runtime function.
Runtime.
Yep. Down a little bit lower.
Container image. Hey, wait, Lambda ASP.NET Core Web. Okay, no, that's container image. So that is still a container image.
Yeah, I knew that they were. I thought they were container. But interesting to see that they've got. You could go ahead and deploy a .NET application into Lambda with Razor, so you could have like proper rendering directly out of Lambda. Like that's pretty interesting.
Yeah. So what I'll just quickly do is new. What do we want? So we want the serverless dot ASP.NET web API, and we want to create a new. Let's call it Lambda API. .NET new serverless ASP.NET web API. Bang. No templates are matching. Obviously, I've made a spelling mistake. ASP.NET Core Web API, that's why.
And let us know in the chat if you've mucked around with Lambda or .NET before.
So when you were working more recently with .NET, Aaron, was it all on Windows machines, or like what was your last public?
So I've been working with a customer who's used to working. So the applications that we're integrating with are actually Microsoft applications. So we're running like SharePoint, we're running different applications inside AWS. And so the other people working on the project are also Windows, sort of Windows-centered application developers. So they're more used to working with .NET and with C#. And definitely working on Windows. So this is the first time I've done it on Linux. And also, this is the first time I've actually done, where are we, source? The first time I've done a brand new install. So this is going to be a fun experiment.
Yeah, the last like actual paid job where I was like working on C# was, or the last code that I put in production there was on Windows machines, and it was not .NET Core that I actually no, that's not right. It was on. We wrote the API that was hosted on EC2 instances, and that was .NET Core running on EC2 instances on Linux, so small instances broken out. We had like what we would call like a distributed monolith, so it was a lot of the shared backend database. There was several different databases, but a lot of these services shared the same backend database, but many different, broken into many different projects that were interacting with that database.
Yeah,
and that was it made it to production. It was an interesting application, but before that was all Windows with like full .NET framework. So this was before .NET Core, so it was a little while ago, and that was probably like must have been .NET 2. Like I don't even know whether it was available in Lambda at the time. We definitely, at the place I was working at, we didn't have access to deploy .NET into Lambda for whatever reason. Maybe it wasn't approved there, or maybe it wasn't working. I'm not exactly sure. But yeah, that was on EC2 instances. And the other work that I've done, sort of been on some side projects with a group of friends who have built some applications, and helped some friends build applications for some other customers. And so we've done it on Beanstalk. So I've successfully helped a customer run an application, a big application, bootstrap it, and start their whole build processes all the way through using Beanstalk with .NET. But recently they migrated to Fargate.
Cool.
So they're ECS and Fargate, yeah.
Awesome. I'll just quickly step through what I did while Paul was talking. You'll notice it went and installed a couple of things. So the first thing that happens when you open a .NET project, it'll ask you to just install all the dependencies. So actually just click yes and click restore, and it'll make sure it installs any of the project dependencies. And then it's basically it. So that the template is up and running and ready to generate or run a web API. So now you can still run this on Kestrel. So for those who don't know, Kestrel is the engine that runs within ASP.NET Core to host the Web API and Web Apps. So you can actually still run on Kestrel by looking at the local entry point. So the local entry point runs on Kestrel. But what you'll notice for those who are familiar with .NET is there's no program.cs anymore. So that's actually been replaced by the Lambda entry point. So this is the guy that actually checks whether we're coming in on a Lambda or whether we're coming in locally. And then it will host it based on, if we're coming in on Lambda, then it will accept basically any requests coming from the Lambda, and that sets up the handler. Otherwise, if we're coming in locally, it sets up the request to come through Kestrel. And that's obviously the startup is the same. So you can modify, welcome to our AWS Lambda API. Let's actually run this. Let's see if I can run this. I've not run it on Linux before, so let's see if it's the same. What do we got? Startup.
For anyone that's not quite sure what Kestrel was, like it's a web server, right? Like it's the replacement web server that sits in front of like .NET Core applications. Yeah. And I think that, like, I don't really know what the recommendation is, but I'm pretty sure the recommendation is like you should front that with something else like Nginx and reverse proxy it. But you could face Kestrel like out on the internet. It'll serve content. I don't know whether you can do SSL certificates and all this, but on Kestrel. But I think the recommendation is to front that with something else like Nginx or Apache or IIS or something.
That's interesting.
Did Kestrel come after IIS? Because that's how long ago I touched a Windows server. Was like IIS 6 or 7 days.
Yeah, Kestrel came out with .NET Core. So yeah, there's still IIS. And you still typically will deploy your .NET Core application if it's on Windows behind IIS, but you can do it directly with Kestrel.
Yep. Okay.
Yep. Is it -- version?
Yeah, it's --
So did you install .NET 5 locally?
Yeah, it looks like it's .NET 5. Son of a. What I can do, let's it just won't. I can still build it and deploy it. It just won't let me run it locally, but I can. It's up to you. I can build it out and deploy it up, or I can install .NET 3.1 locally, and then we can run it locally if you want to have a look.
Well, let's build it out, deploy it, and then see how difficult it is to install 5 and 3.1 side by side.
Cool. No worries. It should be. They're different, so it should be relatively straightforward. It's just the script that I ran will have pulled the latest version, and because 5 is now the recommended latest and 3.1 is long-term support, it would have pulled the 5. But anyway, okay, so what I wanted to show you is basically when running with a .NET Web API, it breaks it into a MVC structure, except obviously there's no view. The view comes from the front end, so it'll just be the model and controller pattern. So everything in terms of all of the endpoints that you set up in your API are coming through controllers. And so this controller, actually, I don't want the route to be API and then controller. I actually want it to be, let's call it V1, because we might want to have multiple versions of our controllers. So let's check a V1 there. So when we actually run this and it deploys our API gateway, it's actually going to come in at the API gateway endpoint URL /prod, and then everything past prod will be the controllers that we set up and the controller routes. So it'll be prod /v1, and then this little guy here, controller, means take the actual name of the controller. So it'll take everything prior to controller here, which will be values. So if we do it will look like this, v1. If we do a query, get query, it would be v1 values, and it would return value 1, value 2. Also, to show that this is working, I'm going to make a quick change to this guy and just say value equals and just say plus ID. So we're actually just going to append the string with the ID that gets fed in the URL. So this ID will come from the actual the route property ID. So let's save it like that for now. Now, one other thing before we deploy it that I want to step through is when you're used to working with the Lambda function, so when you do the .NET new Lambda function, empty Lambda function, you'll actually set up the AWS Lambda the tools defaults. So this is the serverless configuration that you use to deploy. So what we're going to do here is I just need to set up default, and I want to set it in my region is AP Southeast 2. So I already have the AWS CLI installed on my machine. I've already got a profile configured, so I can send up to my account, and I want to create this in the region AP Southeast 2. It's going to be a release configuration. Now, there's actually one important thing that this template doesn't do that helps us to actually package it up better than this is something that I learned what we used to do when we were actually modifying an existing .NET application to compile into a self-contained package. So what we're going to do here is in our template parameters, we're gonna make it a self-contained package. So we basically say it's dash contained. That's all right. Self-contained. We want true, and I'm also going to do a parameter for rewriting all of the assembly name to Bootstrap. Now this is a requirement of Lambda because it actually looks for the Bootstrap when it queries. That's not going to work because it's not when it comes from the web API. Bootstrap. There we go. So that will make it a custom like compiled self-contained Lambda function, which will execute. So in the little Lambda container, it will accept any requests to the Bootstrap, which is coming from API gateway. And the last thing that I want to do here, actually, there's a couple of things that we'll need to do. So to actually make this work properly, we've got a S3 prefix, but we will actually need to specify a S3 bucket as well. So I have an S3 bucket in my account. S3 bucket. And that's going to be, what do I call it? I think it was .NET S3 demo API. I think that was my test environment. .NET S3 demo API. So that should work. And then the last thing we need to do is we actually need to set a stack name. So for you can see down here, we've got a serverless template. I'll jump into that in a sec, but we actually want to set a stack name so that the CloudFormation stack is named, so that we actually have a name for it. Otherwise, if we didn't do these, so if I didn't set the S3 bucket now, and if I didn't set the stack name, when I actually execute the Lambda deploy, it will ask me for all these in the prompt. So now it just will go ahead and execute without actually asking me these questions. So that's the only difference between doing it by default and what the template sets up. And then if you've done it a few times, you'll realize you actually need to set this stuff up. So let's call this Lambda API demo. That's going to be our stack name. Have I spelled that correctly? Yes. Lambda API demo. So that will actually name this stack our Lambda. So what we're actually doing here is we're actually setting up a Lambda function handler. So obviously we're setting the runtime as 3.1. We don't actually need, so we're setting up all the Lambda defaults. We don't actually need a handler. So where are we? Handler. Function handler. Okay, so there's two ways of doing this. The way I used to do it is just say null handler, but by default, you can just specify leave it what's in the template, and it'll use this handler that we're setting up. So the function handler async. Where are we? What we're doing is we're setting up a API gateway. It will be execute API, the region that we've set, the serverless REST API, so the ID that it generates, and it will be at /prod. So this is the URL that will output for our API gateway. And all we're doing is we're at the root, we're accepting any method at the root, and then from the root, any event, we're accepting any method, and we're proxying it to the Lambda function. That's it. So that basically just sets up.
Out of curiosity, like I noticed that that's like in JSON. If you just converted that to YAML, would it work?
Yep. It's the same. This is just your serverless template.
Yep.
So this
and
is
and also notice that there's
CloudFormation
only
template.
256 megs of RAM there. Like it'll be interesting to see how quick it starts up, and whether
Yeah.
like because CPU increases with memory size. Like at 256 megs of CPU, I think you get 1 vCPU.
Yep, and this you would definitely play with if you're actually going to start adding some pretty heavy processes. But remember, this is like a compiled language, not like it is a compiled language, so it actually compiles down really small. So there's not actually as much memory as you would need if you're running like Python or JavaScript. It's pre-compiled and it's executing the libraries.
I think what I found from memory was that C# and Java will have a longer cold start time, and you increase the memory to a certain point, and I think it was like I forget what it was, like 3.7 megs. That's 3.7 gigs of memory, and you get 2 vCPU. And at that point in time, you like the cold start was like really reduced. So had access to a secondary vCPU.
That historically is true. However, we've done a lot of work in Lambda to actually increase the actual start time, or decrease, I should say, the start time. So it actually the compiled languages, so using C# using Java in a Lambda is a lot faster now. There's not as much of a warm-up time required. Plus, you can actually do the concurrency. So you can actually set Lambda concurrency, and that'll keep an active session of the Lambda. So there's a couple of ways around it, and there's even a couple of ways around like adding additional. I'm not going to go into it now, but adding additional build parameters to actually make your code execute a lot faster. For now, I just want to stick with the defaults because I'll chuck this up, and then so let's cross our fingers and hope that this actually works, because I've not actually deployed from this machine before, so hopefully everything's working. So basically that's it. So all we need to do, we've set up our serverless configuration, making sure that I've spelt everything right. Default AULT, yep, AP Southeast 2, right, it's .NET Core. So everything is as it should be. Then basically we should be able to deploy this, and it should work. So let's give it a go. So we don't actually need to use the SAM or the serverless CLI. We can actually use the .NET CLI. So the Lambda packages that we installed before, the templates, actually allow us to go Lambda deploy. And this is a serverless. So this is basically using the Lambda library to deploy a serverless package. It knows that it's going to have a serverless template, and it'll use the Lambda tools defaults to go through and execute what it needs to do. So, okay. Could not execute because specific command was not found. Which specific command? .NET Lambda deploy serverless. .NET Lambda deploy serverless. Okay, you misspelled. Okay, possible reason you misspelled or built in .NET command. You need to execute a .NET program, but .NET Lambda does not exist. That should be.
I wonder if you run it from the actual terminal, if it'll work.
I can try that.
Like it might just be that let's say VS Code was open at the same time. It hasn't realized that you did the install earlier.
No, interesting.
Anything to do with .NET 5?
It might, hey?
Yeah.
Because it can't build it because we don't. Let's try and install.
That's probably what it is. Because I'm sort of looking through the docs, and that command is definitely right.
So here we go. To install runtime instead of the SDK runtime, what do we want? We want...
You want the bottom one, right? And then
Yeah,
change to
I think so.
3.1. Yeah.
Yep.
I can't like running them side by side. I can't remember how you do that. And switch between the .NET versions. So it might be a bit of a pain.
Yeah, let's try. It's probably gonna, yeah, it's still 5. Hey, we could uninstall. So there's the .NET 3.1. Let's have a look at, let's look at it the old-fashioned way. Where is it? Home Senpai.net. Yeah, so it should be right here. I wonder. So there's the 3.1 SDK.
There was a way to do it. I'm trying to remember like what it was, because it was probably 6 months ago when I was doing this.
The 3.1 is there now, so I should actually be able to, let's just test if I can run this locally now that it's got 3.1 installed. Yeah, so there you go. So we actually, potential risk.
Well, that's probably because you didn't do that install local certs command.
Oh, what do I have to do there?
I can't remember what it is. There's a command that will install the local certificates so that they sign locally.
Oh, yeah. I did that ages ago. I don't remember what I did to do that.
It's like some command it sort of tells you. Let me see if I can find it. I did it today because I'm building a containerized application. Here it is, .NET. I think it's this. PowerShell. I think it's like .NET Dev Certs HTTPS or something or other. Generate the self-signed certificates. I think it might be this command, Aaron. I'll paste it into the chat.
Yeah.
Did it? I think it went funny because it was on two lines. I think it didn't copy and paste properly.
It's on one line. .NET Dev Search HTTPS IP environment
so
user
when you run
profile. Specify help for list of available options. Doesn't like it.
This example used PowerShell. That example was we need to find how to do it with not with PowerShell, just like in shell script.
Yeah. But I can see that it's not a problem before I tried. Where are we? Terminal.
I think if you accept that warning and go forward, it'll work okay.
Which warning?
Like accept the SSL warning.
Oh, yeah. Let's try and do this again. Yeah, welcome to our AWS Lambda. So that's hosted locally. If we go to v1 dash
Oh,
values.
it's actually a huge pain, or it looks like, to do it on Ubuntu. So just
value
accept
1,
it and
value
move
2.
forward.
Yeah, I've done that. And
Yeah.
ID 123, and so that says value equals 123. So,
yep.
Or 987, bang. That's simple as that. So that's the actual controller accepting. So that's running locally, right? That's not where we want to go. Well, I'm not sure why. Let's just make sure we have.
What was the problem you were just trying to fix then?
Well, I've the what I want to fix is actually doing the deploy. So I've
so the deploy still is not working.
Yeah, I've installed the Lambda templates. Now, usually,
what about if you run .NET version here? Does that work? Like, just check what
.NET
version it is here.
Yeah, I did. It still says .NET 5, but I can the two can run side by side, but I think actually probably because what I need to do is, if I remember correctly, it's .NET tool, but I didn't see .NET tool installed. Let's try this. Globally, we want to install the Lambda tools. Because I didn't install the Lambda tools. All I installed was the templates. So all we've done at the moment, Lambda, is install the templates so that we can create the application. We haven't actually installed the tools that will allow us to actually execute. I think that was probably what the problem was.
There is a thing on Stack Overflow. Like run this command.
So this should help. Oh, I just need to add this to the. I'll just do it to the current session. So we've got tools. So I should be able to run this again now. Why can't I? There we go.
Yeah, I think what Matt said is we'll fix it.
What did Matt say?
Well, what you can do is you go .NET list list SDKs. So what Paul's just mentioned in the chat, and then after that you do .NET new global JSON, and then you go --SDK version, and then grab that second version of 3.1.0. whatever it is on your machine, and that seems to switch it according to about 3 different threads that I read.
I'm not so worried about it because you can have them. They're executing side by side anyway. Because we just ran the .NET app in 3.1. So we just ran a 3.1 app locally. What I need, Amazon Lambda tools is already installed. Okay, cool. So now I've installed tools. I should be able to
run that command again. I think you're right. I think it's clever enough to pick up like what's defined in that particular project folder as the runtime. Still an error.
The library should exist in tools, Amazon tools 5.1, Amazon tools. Yeah, it looks like it's a problem because of the .NET 5 installed. Maybe let's just try what we tried before. Let's close this and try that again. See if we can do it in the terminal.
Because that command that Matt says basically says that it will look to that JSON file and pick which version to run. So I don't know. I'd be curious to see how it works.
All right, let me just try this and then we'll do that. This doesn't work.
So, you're missing an E. Yep. Yeah, to be honest, I've never used .NET ever, but
it's don't net. You typed it wrong.
Don't net.
I keep typing botnet as well.
Yep.
No, it doesn't. Yeah, because I haven't even.
And I can see that raw coders are watching us. So say, hey, hey, you guys, how's it going? Hope it's all good on your end. I know that your stream starts in 10 minutes, so don't want to hold your setup up.
Yeah, same issue. So it's to do with my actual environment. As soon as we sort out this, so what were you saying before, Matt? What do we need to do?
Could you go .NET and then just go --list SDKs? Yeah. So what we're going to do next is .NET space new space global JSON, one word, and then space --SDK version, and then space, and then type that 3.1.412, and then try it again. So this changes the CLI. So it does pick up for the builds in the project, like which version you're using, but this should change the CLI over.
So if you did .NET, no, it's still
same issue.
But it's still looking in that core folder as well.
It's looking for something. Fatal required library libhost fixer.so could not be found. So it might be because I might need to add this the same way that I added it, because I know what it is. Let me open another terminal. We need to add.
Is this some sort of like package thing or something?
What's the zish rc
.zshrc?
Yeah. Where is it? It's in the home, isn't it?
Yeah.
Yeah. ZSHRC. Yeah. I might quickly drop, guys. My wife's got early shift.
Yeah.
But I'll leave you to keep going. I'll be interested to see if this works.
Is it because you added those additional flags to make it self-contained? Aaron, can you just delete that out?
Delete what out?
And not worry about the extra, like, you know how you added,
no,
what was
I can try that, but I'm pretty sure it's because it's missing. It's looking for the tools.
Okay.
So it should have tools, but it's not on the path. .NET Lambda's there, but it can't find it. So let's try that. Wait, that should be tools / shouldn't it? Anything inside the tools folder.
You'll have to source that file to, yeah. So do source. And then like that file.
Which file?
tilde.zsh.rc. It'll be like / or a /.
Huh?
Like you use autocorrect to get it. Yeah. Yep. Yep.
Nope.
Nope.
So we've added tools. That
In the chat, I sent you like a bunch of path exports that are recommended to export as well. Let's just have a look at those if that's what it is. If it's missing something with the .NET tools.
So I just added the .NET tools. I haven't added the other stuff. Let's add this other stuff. So that was the top one that you just said is the one that I just did. So let's do that again.
Because it is saying there, like, use .NET root environment variable to specify the runtime location.
Okay, so how do I? There we go. .NET root snap.NET SDK current export.
That .NET root is probably wrong, right? We need to find where it is for you, like where .NET is installed to, because I'll assume you did not install .NET Core with Snap.
No, I didn't. So the .NET SDK is inside this .NET folder /SDK. So .NET SDK current, let's just have a look at, if we look at, where were we before? Home folder. .NET. So there's the SDK. So what's this trying to do? This is the .NET-SDK current. I don't know what that is. So there's my SDKs, but I'm not sure what that line is that you gave me. So that's saying the .NET root. That would be this folder here. So this, what I wrote up here, .NET, is the .NET root. That's where the actual .NET service is. So I'm assuming that's what this is looking for, .NET root. You reckon?
I'm not 100% sure, like what
Well,
it's
it looks
asking
like
for
it because you can see here it's saying MS Build SDKs is in .NET root /SDK. So that would be this guy here.
Yep.
The .NET root,
that looks right.
Which is
Yep, that looks right.
Well, it's looking for 3.1.4. Okay, so that is getting the current .NET. That's going to be different to because.
So that .NET root is probably to that folder there. No, that's not right. The .NET root is exactly what you said.
This is .NET root to .NET.
Yeah.
So we should change this. I'm not sure that that's right because it says it's using. Oh yeah, .NET root .NET and get version.
Yep.
Yeah. I see what it's doing there. It's execute. Yeah, so that's correct. So this should actually be root equals.
And I think like maybe we change that .NET version and we hard code that .NET version there.
We don't need to because it's doing the .NET get version and then /SDK.
Oh, okay.
So it's getting So that's executing that function, that get.NET function. Anyway, this should be correct now if we do home.NET. That's our .NET root. Path home.NET. So that is actually exporting the same as that up there, path and .NET root. So actually, let's not duplicate it. Let's get rid of that one. And .NET tools, yeah. So I had already added the .NET tools, and you've added the path home .NET tools, same one. So let's make sure that we're not duplicating again. So we've got .NET root, path, the tools version. So that's almost pretty much the same as what we had before because we had .NET and .NET tools. I'm not sure that this is going to help, but we'll try that anyway.
Maybe it was specific looking for that .NET root environment variable. Let's see.
Maybe we'll give that a go. Let's start again. Hey. No file or directory, user local bin, user bin. Didn't like something.
I didn't see what you did there. You did it so quick.
I just closed the terminal, started a new terminal, and it's creating.
Oh, okay. So something. No, that's weird.
Console
Maybe something with
during
that .NET command isn't. It's not happy.
Home Senpei, no such file or directory. So on line 111. There's no SDKs directory, if that's what it's looking for. There is an SDK. Oh, wait, then there's a 3.1.
I think you can comment that line out, that MS Build SDK paths line. Just comment that one out.
Here we go. It's looking for this SDKs. So these are the. So it's there. I don't know why it doesn't like it.
Yeah.
Let's just do
Where
this
it's got
instead.
that .NET version, just hard code that to 3.1.4.2.
Thinking the same thing. So this will become. That should be on the next line. SDK 3.1.412. SDKs. Let's try that.
I think you might need to wrap all of that in quotes. I think that might be causing some funny things happening.
No, that worked.
Okay.
Nope, still doesn't like something. Fatal error. Lib host fx could not be found.
Yeah, do an echo of the .NET root.
Fatal error required. Blah blah blah.
So didn't you change it to be a non-self-contained application and see if that fixes it?
Okay, I don't think that will have anything to do with it, but we'll give it a go. If we just remove that. Same thing. It's looking for something.
Like do an echo .NET root, echo $.NET root, and just see whether that variable is set correctly.
Was it .NET?
I think it was .NET underscore root.
Yeah, .NET underscore root. Yep.
I mean,
Senpei /.NET. That's where it is.
I mean, but that's the whole variable. That's like, that doesn't look right.
So that's the home. That's the home path. All right, well, we can hard code it if you want.
Let's just just put that in. Have a look at that file again. Yeah.
Whoa.
Yeah, you just missed the tildes. Tilde slash.
Huh?
You didn't pick it from the root. You opened the file from where you currently are working from. It's tilde, yeah. Yep. So yeah. So see, .NET root is wrong because that's saying like the whole path, and we don't want the whole path. Yeah, delete the path bit. Yep. Try that. You'll have to start the terminal again or source that file.
Yeah, there you go. But I doubt that. Hey, that was it.
That was it.
That was it. All of that. So it's just environmental variables. How annoying is that? All right. So
Yeah,
it's
just setting it up to point to the right location of the SDKs.
Yeah.
And I guess that's what it was telling us there, right? Like the runtime. So what did it say there? If this is a self-contained application, that library should exist in this specific location.
Yeah.
So obviously it didn't. So if it's a framework-dependent application, install a runtime or use .NET root environment variables to specify the runtime location.
Yeah. So it was just environment variables. There you go. Well,
Yep.
At least now my Linux environment's set up for the future. But you can see what it's doing now. It's just deploying the actual Lambda API demo stack. It's building the serverless REST API.
Did you redo that command that we deleted out?
The self-contained?
Yeah,
it's still there.
Yeah, you did. Okay, cool.
So there you go. That's done. So we now have our API. Let's hit the same thing from.
Okay, I mean, that cold start is pretty good, right?
Yeah, that was pretty quick. And let's go to, so it's V1, and try the first one, which is values. There's your values. And let's go to, let's say something, it's looking for an int. So let's say something random. There you go. So it was deployed there and then. So like that's it in terms of like building it out or deploying it up. Where you go with this is like the work that I have been doing with this specific customer is actually instead of, so we started with actually trying to build out, like we built the Lambda endpoint, we started massaging the existing application, but because there's a lot of legacy stuff in it that we want to avoid, what we actually started doing is we just started creating new controllers. So new file, let's go like weather controller. So if you remember like the old web API, ASP.NET Core web API, it creates like this weather controller and it does this random weather, what do you call it? It's like just random weather data that creates 5 instances. So I'm going to use that as a basis for like showing like how easy it is to add to it, right? So if we instead of like in the old web API scaffold, in the old template, it actually creates it in the root, the service. What I actually like to do is I actually like to create a services folder. So then all of my service classes go into the services folder. So let's add a new, let's call this weather. So this would be the weather service. So basically, essentially, like obviously I'm not creating a weather service for the customer. What we do here within all the services file, this is where we install the AWS SDK. And so we can actually start to access all of the AWS services that we need to integrate with. And then for the purposes of this, I'm just going to quickly copy over the default template code. So all I've just, that's the wrong one. That's the controller. Let's find the weather service. So all I'm doing here is obviously it's .NET. So using system as the basis, namespace. I just pulled this from a demo before. So this is our Lambda, what did we call it? Lambda, is it? Helps if we just do this. Lambda API under services. Obviously, for those familiar with .NET, we're going to chuck it in the services name, like the namespace for the folder that we've chucked it in. Makes sense. Don't have to. You could put it in the namespace for Lambda, and then you'd access it anywhere. But I like to keep my namespaces in line with my folders. We're calling it the weather service. All it's doing is it's providing a date, a temperature in Celsius, temperature in Fahrenheit, and a summary. And so this is basically just you could even use a struct, like it's just a class to hold the data so that we can instantiate a couple of things on the controller. And that was what we pulled across before. We don't actually need link. We don't need threading. We'll leave system in there. And this is the Lambda API. So you can see that I was playing with this on my Windows machine that I'm pulling it from. And actually, this should be... Crap, I've copied the wrong one. We want the weather controller. Helps if I concentrate on what I'm doing. So we want the Lambda API. Okay, this is another little thing. Probably people are going to look at me going like, what the fuck? I mean, what the hell? Sorry. Using inside a namespace. This is just so, like, for those of you who aren't familiar with, actually, if you put you're using inside your namespace, it's actually going to look for within the services before it looks for anything outside. So it's not such a big deal like when we're such a small application, but when you're actually working with really big applications and you start to build out namespaces like math or things that actually make sense in another namespace, this is one way of being able to control which namespace overrides the other. So this is just an old practice that I've sort of picked up years ago. So any of my own internal namespaces always come under the Lambda API. So I don't actually have to call Lambda API because it's inside the Lambda API. Then you just call services. Yeah. And then actually the service that it's looking for is the weather service, which is here. So now I don't actually have to go, Lambda API.services.weather service, or I don't have to using, if I was to put it above the Lambda API namespace, then I'd have to do using Lambda API.services. But because it's inside, it's just services, and you've got direct access to that class. So that's the weather class over here. And then, as I said, we're just instantiating we're creating a range, enumerable range of 5. So it'll create 5 instances of the weather service. It'll give it a date of days and adding the index. So whatever the date today is, plus add whatever the current index is. The temperature, it's just picking a random between -20 and 55. And then the summary is just summaries of random range next summaries.length. All right, so it's just creating random, and then it's creating an array. So basically this will just output 5 random weather data, bits. And then all we're doing is, okay, so this I've left in there because for the project we're working on, we want everything logged out to CloudWatch. So actually we create a logger that we can inject. So the same way that you do in a .NET application. So you can actually set up your inversion of control in the startup. So we would actually inject in the inversion of control in a dependency injection. So this is the constructor for this controller. We're injecting our logger. It just has to conform to the iLogger class. But actually the logic inside our logger class, I don't have it here in this Linux project, but the one that we're working basically just says anything that's logged to logger. So if we're using logger in any of our functions to log, like output, then send it to CloudWatch. So we're just basically sending all of our logs to CloudWatch, which is different if you're running it on EC2 or whatever. And that's it. So we've annotated it as a .NET, so as a GET request. It's going to return a list of weather service objects, and that's it. Oh, the summaries. Here we go. So it's getting the summaries from the string array of summaries. So if we save that, let's just say, actually, we want to say it's v1/. So let's make sure that we keep it on the same version. So that's v1/. Same deal. Anything that's controller is only going to take what's before the controller. That's it. So we've just added a controller. We've added a service. Let's pretend that this service is talking to other services inside AWS, and we're using the AWS SDK here. Lots of fun. good at imagining things. Let's do the deploy again. Let's just do exactly the same thing. So that's now just pushing the whole thing up again, redeploying the, it's actually the change set. So it shouldn't actually redeploy the entire API again. It should just update it. So it should be a bit faster than last time. There we go, update complete. There we go. So the beauty of using CloudFormation, you don't have to redeploy everything every time. And there is our Lambda API. And now we go to v1 slash, what do we call it? Weather.
Weather.
There you go. 5 random weather instances. And how fast was that?
It's really nice.
Yeah. So that's .NET running in Lambda with an API gateway proxy. So the Lambda is actually handling all of the request methods, all of the request resources. So essentially, like, this is one structure of doing it. So this is controller-based structure. So for the controller, then you add the get property, or let's go back to our other one. You can add the get property, the get value.
That's your method, right?
Yeah, your method.
Your verb.
There is another way of doing it where you actually use function attribution. So instead of put, post, get here, where these are the actual methods, you can actually create a name. So you would be like v1 slash controller. So values slash, if you wanted an additional route property, your function name can become a route property, and then you attribute the route, the function name with the type. So the actual function name might be a post, but then you have, so it could be values slash my data. And so you'd be doing a post to values slash my data, and that would be the function name. So that's just a different way of doing attribution and routing. Depending on what you need to do. I think the simplest way is creating a controller and then just that controller having the different properties. That's the default and the simplest way. But you can basically copy anything that you know from .NET Core, ASP, or Web API and Web Apps, the same structure into your serverless Lambda function, and it'll just compile it down as a self-containable and run it as the application out of Lambda.
Yeah, awesome. Well, I think I'm going to get ready to pack up and head off to bed, but I reckon we should, I'd like to see this was like as a proper like MVC app or something rendering Razor templates out as well.
Yeah.
People are always asking those sorts of things. And that would be interesting to do. And then maybe because most of those, like any of those MVC or Razor apps or whatever, you're going to have, you're going to like using the standard like .NET like login and authentication. And then at some point, maybe we like push that off to Redis as well. And so that you can run stateful applications within Lambda.
As a little interesting point, the application that we're actually running, so this integration, we're actually using our new memory DB. So it's actually it is actually storing. It does have some state outside of the Lambda, which is just using the memory DB, which is pretty cool. So that's the first time I've used memory DB. Yeah,
awesome. Well, just for anybody that isn't aware, like memory DB was released like this week, just a few days ago, and is Redis compatible. However, it is durable. So if anybody's used Redis or Memcache, you know that like that is not durable. If that machine reboots, it's gone. It's in memory. However, this is durable, so you can actually use it as your persistence engine. So like as a database, as a direct replacement for like SQL Server or something like that. I mean, obviously you have to code because you're using a different engine, but it's durable now. So you have like this, super fast in-memory database that is completely durable. So, yeah. All right. Thanks so much, Aaron. Like I know you put a lot of work into this, and it was really good, and we had to like piece our way through it. As always, it takes 45 minutes longer than we think it will. But yeah, really nice to see. And
I thought my environment would work after installing .NET, but clearly there's some environmental path parameters that I missed.
Yep. And maybe another time we'll touch base with it on containers as well.
Yeah, cool.
But yeah, it should be good. I think it's like worth sort of like setting up some instructions around this, because I feel that it's not widely documented. exactly what to do to get to this step. There's sort of a lot of poking around to get to that. So, that sort of, I think Matt is still watching in the background, but it sort of ties into what Matt and I might be going ahead and demoing and working our way through tomorrow. A mechanism that we could have, information displayed to other people using some easy to use services on AWS. So for anybody that wants to come on tomorrow, that's GMT +10, so Melbourne time zone. Devs in the Shed on the AWS Twitch channel, so we'll be streaming from them as well. But yeah, thanks a lot, Aaron, and yeah, everybody else. Good night, and see you all next time. And thanks for watching.
Good night.
Bye.